Okay, so I want to make sure I go through a couple of examples of how to solve systems by elimination. And so we're going to go ahead and get started. The point of this is to solve for each variable at one time. So the best way to do that is to eliminate a variable, hence the name elimination method. Okay, so just to get started, for these two equations, I'm noticing already that I'm going to need to put the x's and y's in the same position. So for this first one, I'm going to add that 3y over, 4x plus 3y, and I'm going to subtract the 5 over to the other side to give it a negative 5. And then I still have the equation 8x plus 4y equals negative 6. Now I'm trying to eliminate a variable. I think the easiest variable to eliminate would be the x, because if I multiply this top equation by a negative 2, I'm going to get negative 8x minus 6y equals positive 10. Okay, and if I throw that underneath this other equation and combine these equations, it will eliminate the x variable. So I have negative 8x minus 6y equals 10. And again, I'm going to go down and combine the like terms. So 8x minus 8x could be 0 x's. I'm going to have no x's left, okay? Here I have 4y and negative 6y. Together they create a negative 2y. Negative 6 and positive 10 create 4. So if I solve for y, I get y equals negative 2. So for my final answer, I'm going to have something, comma, negative 2. Now I'm going to go ahead and put that negative 2 into one of my equations. Okay, so I'll just go ahead and put it in this equation right here. So I have negative 8x minus 6, but instead of the y, I know what y is now. I can put in the negative 2. Okay, and I'm going to equal 10. So negative 8x, we're going to go ahead and evaluate the negative 6 times negative 2 to be positive 12, equals 10 still. When I subtract the 12 over, I get negative 8x equals negative 2. And when I divide, I'm going to get a negative 2 over negative 8, which actually reduces to a positive, because negative divided by negative is a positive, 1/4. So my final answer would be 1/4, comma, negative 2. Here's another system that we can use elimination to determine the solution. And so when I'm looking at the x's and the y's, I notice that there's an easy multiple of this second equation that would eliminate the y's from the first. What I mean by that is, if I multiply this second equation by 2, my y's in this equation are going to become negative 14y, canceling out my positive 14y from my other equation. I'm going to go ahead and rewrite this. I have 8x plus 14y equals 4. And if I multiply the second equation by 2, I get negative 12x minus 14y equals negative 20. Now, if I combine these equations, I get 8x minus 12x, which is negative 4x. My y's are canceling in this case. They become 0, equals 4 minus 20, which is negative 16. Divide by negative 4, and x is positive 4. So I have part of my answer here, 4 comma something. Okay, so let's substitute that 4 in for x's in one of the equations. I'm just going to make it easy for these purposes and just use this bottom one. So negative 6 times 4, I'm substituting in the 4 that I just found, minus 7y equals negative 10. So I have negative 24 minus 7y equals negative 10. Add that 24 over, and I get negative 7y equals positive 14, which when I divide by negative 7, I find that y has a value of negative 2. So solution for this would be 4 comma negative 2.